I do. Dunk, what'd you eat at Super Bowl? Did you watch the Super Bowl? Duncan! What kind of family doesn't watch an American holiday? It's on regular TV. You don't got bunny ears? Good for you. It's a little weird for me, but do you have internet? Do you have Facebook? They could have watched on Facebook. Facebook Live. That's an important one. I almost had to switch my provider. Somebody told me it was on Channel 5 and DirecTV's having issues with Channel 5. I almost got me a whole new service provider so I could watch the game because that's how important it is. My one holiday for the whole damn year, that's about what I care about. You're dead to me. Okay, so first off, you're using stuff that I have no idea about. I know about Six Rings, but then you said the word Thanos, and then it just like, who the hell's that? I've heard of him, like he's a Marvel dude, and that's all I know. And he probably killed everybody. I think I've been told about that. See, that's what I'm saying. See? I saw those things about Avengers coming up, and all of everybody at my party was like, "Ooh, I'm so excited!" I'm like, sleep. Like it would be a $10 nap if I went and watched that show. And then who is Captain Marvel? Some lady. I didn't even know. So that's another one that I'd be all like, take the kids and I will stay home. No, hell no. I am not. No, I am not. It's okay if you guys are into that. That's awesome. The only reason why I've seen Thor is because I kind of have to at this school. As soon as I'm gone, if there's more Thors, I'm like, I don't need to know this anymore. Does it have some posters? All right. 150 degrees, ladies and gentlemen. I'm going to draw 150 degrees. Oops, that's great. Okay, 150 degrees. Would you guys agree it's somewhere over here? Yeah? And if I draw this out, that's its terminal side. I can always make a terminal side into a triangle. Can somebody tell me if this right here is 150 degrees, what is this part right here? That right there is 30 degrees. Does anybody know what that is called? That could be a supplementary angle. That's very correct. In this case, it is a supplementary angle, but it's also called our reference angle. Okay, a reference angle is basically what fills us back in to get to 180, gets us back to 0 or 360. Because what's going to happen is I could then pull down that and make what kind of a triangle? A 30, 60, 90 triangle, or just basically a right triangle, couldn't I? Because it doesn't necessarily have to be a 30, 60, 90 or a 45, 45, but it does make us a right triangle. And right triangles cannot be larger than what angle? 90. An angle in there cannot be larger than 90 because we already have a 90-degree angle in there, correct? Would you guys agree with that? Okay, so that extra angle is called a reference angle. And that's also, if you think about it, remember, guys, the coordinate, remember what's the coordinate of 150? It's negative root 3 over 2, comma, half. What was the coordinate of 30 degrees? Square root of 3 over 2, comma, a half. And that's the reason why they have the same coordinates, because they have the same reference angle. Is everybody there with me? Yes, no, maybe so? Can somebody tell me, okay, who would have the same value as the sine? Excuse me, let's not do sine. let's say, no, never mind. Screw that all. Done with, oh, okay, we can do that. Yes, that's good. Let's say the cosine of 120 degrees. Who would have the same angle as, or equal that? I know what this is really quick. The cosine of 120 degrees, that is the x value at 120 degrees, which is negative a half. Okay, without using the unit circle, where would another cosine give me a negative a half? Without using your calculator, okay? How many of you guys remember that I showed you all students take calculus? You guys remember that? Did I not put that on your thing? Okay, so all right, here's the first time then. Maybe learned it last year. So, with that being the case, what does A stand for? All of them are positive in quadrant 1. That's what that's standing for. This is standing for in quadrant 2, sine is positive. And that should make sense because sine's the y value, right? Isn't the y value in quadrant 2 positive, but the x value negative in that quadrant? The x values in this quadrant are negative, but the y values are positive, aren't they? And that makes sense why sine's then positive. Okay, what about tangent? Why is tangent positive here? Well, tangent is y over x. And in that quadrant, both y and x are negative. So when I do a negative over a negative, that comes out to be a positive. Hence why cosine is still negative there and sine is negative there, correct? What about C? Cosine is positive. That means sine and tangent are negative. Okay, so really quickly, 120 degrees is right there, correct? Would you guys agree that's 120 degrees? What's his reference angle? 60 degrees. Do you guys understand that 60 degrees here? Yes, no? So knowing that my reference angle is 60 degrees, where else is cosine negative? In which quadrant besides quadrant 2? It's also in quadrant 3. So for it to be the same value, they need to have the same reference angle. Does that make sense to everyone? So ladies and gentlemen, if they both have that same reference angle, that means they have the same cosine value if they're in the same spot, right? So what would be that angle measurement? 240. And if you looked on your unit circle, both 120 and 240 degrees have a x value of negative a half. Hence why they are the same value but different angles. Does that make sense? There's multiple angles that can give you that same value between 0 and 360. Okay. Let's say if I write off something else. Let's say I write, all right, 213 degrees. What is his reference angle? Well, let's look. Oops, that's it again. Where is 213? Which quadrant? We're in quadrant 3, so we're coming around something like that, correct? Yes, sir? It's not part of your test, but you can have one that you can fill in for yourself. Yes, sir. So therefore, remember our reference angle. What is a reference angle? It's an angle that makes us back to a right angle. We always make our right angles back to the x-axis, never to the y. Okay? So, ladies and gentlemen, how much do we know is from here to here? But the green is all the way to 213, right? So what is our reference angle? 33 degrees. Is it 33? Yes. 33 degrees would be our reference angle, because that would be 213 minus 180, correct? Yes, no? We feeling good? Now, is all of our angles always going to be in degrees? Could it be in radians? Okay, so let's do that same thing. Let's say if I had 9 pi fifths. 9 pi fifths. What quadrant is 9 pi fifths in, you think? Fourth quadrant, because 2 pi is 10 pi fifths, right? Does that make sense? And so this would be 10 pi fifths right here, because that's 2 pi. Notice this guy right here is 3 pi halves normally. How does 2 become a 5? Times by 2.5, right? What's 3 times 2.5? 7.5, right? Oh, yeah. So this would be 7 pi, 0.5 pi over 5. Why did I just do that? So I can guarantee that it's in that quadrant 4, right? Does that make sense to everybody? Because sometimes it's harder to see where it's at when it's not 0 to 60. Would you guys agree? Okay, so if when I draw that, I'm all the way over here somewhere. Okay, that's my 9 pi fifths. What's my reference angle? Always back to the x-axis. That is so true. So it would always come up to the x-axis. So this would be my reference angle. Pi fifths, right? Does everybody understand why it's pi fifths? Because 9 pi fifths plus that pi fifths was get it back to 2 pi, correct? Yeah. Closest x-axis. On the axis, then it doesn't have a reference angle. Then it doesn't have a reference angle. It's just the angle itself. Because you can't build a triangle. And that's the whole goal about a reference angle, is building a triangle, right? Does that make sense? Everybody with me on that? Is this okay? Am I like being a bad teacher if I'm sitting down doing this? Or you guys, are we okay? Anybody dying because I'm horrible teaching code right now? Huh? Let's just try this today. But I think I might do this one period just so that I get right here and then you guys can hear me in the, you know what I mean? Okay. Let's go to another one really quick. Let's talk about 2 radians. Two radians. What's its reference angle? So which quadrant am I in first? 2. That's correct, because if you think about it, 180 is pi, right? And pi halves is, so pi is roughly 1.34. Divide that by 2, you get 1.57. So therefore, it's bigger than 1.57 radians, but less than 3.14 radians, right? Does that make sense why we're in quadrant 2? You with me there, Mr. Clarkey? Okay, there's no difference. The reason why most everything is in terms of pi is because we're doing things in, like, on a circle. Notice a half a circle is pi, so half of a half is 90 degrees, you know what I mean? So that's pi half. But do you recall the very first day what 2 radians even meant? No, that's 2 pi radians. Remember how I used the headphones and I took my radius and I went around? And that's why, remember how we went 3 and a little bit, hence where pi came from? So therefore, remember this is 3 and a little bit was right here, and 2 radians was somewhere up there, right? Remember that? Using the headphone idea. So a lot of people get confused when we see 2 radians. Does it have to have a pi with it to be in terms of radians? Not necessarily, right? Does that answer your question? So we do know 2 radians is somewhere up here. I'm just sketching. We all know that we're sketching here, right? So what would be our reference angle? This angle right here. What do you think? No problem. So radians, so here's my whole circle, Taylor. So if you recall, we took the measurement of this radius and we put it on, so like this was 1 radian measurement. It's putting your radius on the circle. Exactly, so it could be 5. But notice there is still that ratio of always going around any circle, that it will always take pi of your radiuses to get around to half of the circle. Okay, does that make sense? Okay, so I don't want degrees though, because I'm in radians. So really, guys, how much do we know is from here to here? Pi. How would we find this amount? Well, aren't we going to take pi and subtract how much? 2. And there it is. That's our reference angle, because as soon as I put pi in a decimal, I'm estimating, correct? But if I did put it as a decimal, what would it be roughly? 1.14 radians would be my reference angle, correct? Hi-ho! Happy day! Why? Why would you want to do that? Am I really an opposite person? I am sometimes a devil's advocate. Yeah. I'm already testing pretty quick on Happy Monday. Yeah. I'm thirsty. Yeah. Today's Tuesday. Yeah. Tuesday. Because you're going to teach 4-4 tomorrow, which is Wednesday. Yeah. And then a review on Friday. Are you really? You're not even a blonde. What are you? What's your natural? I don't think I've ever seen your natural. Should we pull up some Facebook? Mr. Clark with the Puma? You're a dirty blonde? I was a dirty blonde when I had hair. Really? I'm a chingy down here. Yeah. No. We'll go to Facebook. When I had hair. Let's go to Facebook. Moons ago. Okay. Oh, I'm recording this. I don't want recording. Thanks for Facebook memories. Where's the location of -3, 4? Would you guys agree it's up here? Okay, so I'm over up 4, 1, 2, 3, 4, over 3, 1, 2, 3, right? Could I find all 6 trig functions from that point? Okay, I could draw that triangle. So far, I don't need that reference angle, but I could, right? So this right here, what's this value? 4, what's this value? -3. Remember how we talked about how sides of a triangle cannot be negative? Well, in this case, they are because of the fact of where the location of the triangle is located, right? It's quadrant 2, so therefore the x value is negative. You guys agree with that? Okay, what's this value right here? 5, 3, 4, 5. Now notice I could find all 6 trig functions, couldn't I? I could find sine 4/5, cosecant 5/4, and so on. I'm not going to go through that because that's kind of blah, right? But if you have one thing, you know everything, correct? What is the angle? What angle gives me those ratios? Let's find it. So let's say right here, here's our angle. Now that's our reference angle, but this is really, that reference angle is going with that angle that's going from here to here. Does that make sense? Let me explain what I say by that. So like 150 degrees. When I say the sine of 150, that's the same as the sine of 30. Correct? Do you guys agree with me there? Because they have the same reference angle and both sine is in quadrant 1 and quadrant 2 the same. Right? Okay. So let's find this. So if I go ahead and say sine here, I'm going to go, okay, sine of theta, which I'm not sure of, is 4/5. Then we take the inverse sine. So theta would be the arc sine or inverse sine, I like to say arc sine personally, 4/5. Go ahead and let's plug that in our machines, please. I got a 53.13. Okay, does that angle from here to here look like 53.13? It's not that angle. What angle is it? Our reference angle. Why? Well, the very first angle that sine is 4/5 is in quadrant 1, so that's what they're going to give us, is the thing in that. So therefore, I can use it as a reference angle. So therefore, once again, this was 53.13. So therefore, what's this angle right here? 53.13. Right? But what's my true angle? What's this true from here to here? How'd you get that again? Does everybody see that? So that angle right there is technically theta is 1, as you said, 26.87. Somebody plug that in and do the sine of 126.87 and you should get pretty gosh darn, is it going to be exactly 0.8? No, because we estimated, right? We cut it off a little bit. But if I did the sine of 126.87, I should be basically 0.8, shouldn't I? And did we get it if you put it in? Okay. Any questions there? We doing okay? Okay. Here's another great question. All right, let's say this time. Sine of theta is 2/5. But the cosine of theta is less than 0. I would like us to find the secant of theta. And I want us to know what theta is. Can we find theta right now? Okay, let's go ahead and do it. Find theta right now. How do we do so? We're going to take the inverse sine, right, of 2/5. Inverse sine of 2/5 because of up here. What do we get? 23 point, I'm just going to go 24 degrees. Is that okay for everybody? 24 degrees. Okay. But well, that doesn't make sense to me. Because if I did the cosine of 24 degrees, would that be less than 0? It wouldn't, would it? Cosine of 24 degrees would be positive. So which quadrant am I in? Well, let's come over here. So sine is positive in quadrant 1 and quadrant 2. Would you guys agree? That's what we talked about. All students take calculus, right? Whereas cosine negative, though. 2 and 3. So which quadrant am I in? 2, because that's where they overlap and that's where they're sharing. Does that make sense? So technically, I have this. So I have 2/5. Give me 1 second, Daniel. By the way, guys, this is negative root 21. Does everybody understand how I got him? I just did Pythagorean theorem because that's 25 minus 4. Okay. Is everybody good with me? Okay, but notice, what is this angle that I just got, though? It is my reference angle. So therefore, what is theta? Because remember, this is 24 degrees. So therefore, this is 180 cut back 24, which is 156. That's what theta is. Right? Is everybody there with me? Any questions? Tom, you good? If I was asking for theta, yes, because that's the quadrant that I'm in. Yes. The reference angle. You can. The only time that you can is if you're in quadrant 1, you'll always get your angle because in quadrant 1, that's where it's always telling you, right? Your reference angle is the angle itself. And the other time that it actually does is when you do an inverse cosine and you're in quadrant 2, it'll give you the angle. And that'll come more in next unit when we talk about graphs. And I'll explain that a little bit better then. But right now, I think if I start getting into it, it'd go way over right now. Does that make sense? So can I hold off that question a little bit till next unit? Okay. But understanding that most of the time they give it to us, it's going to be a reference. Okay. Answer your question. That's why we're thinking, where should our location be? And 24 degrees, oh, we're not in quadrant 2. 24 is not in quadrant 2, so that's our referencing. Okay, so other thing, we found theta. Now let's find the secant of theta. So secant, if we all know, is the opposite of sine, or the reciprocal of sine, not sine, hold on. Cosine. Anyway, see how I put that in there? So cosine is adjacent over hypotenuse, so therefore secant is hypotenuse over adjacent. Do I like root 21 downstairs though? What do we need to do? Rationalize, so that's -5 root 21 over 21. I just times root 21 top and bottom, didn't I? Was that too shabby? Okay, really quick question. What quadrant would I be in if tangent was positive? So new question here. If tangent was positive, so greater than 0, but cosine is less than 0, what quadrant would I be in? Let's think about it. Don't shout it out. Let's think for a minute. Did anybody shout it out if you did? Hold off for just a second. So what I like to do is I say, okay, tangent is positive in these two quadrants, right? Cosine is negative in these two quadrants. Where do they overlap? Quadrant 3. So our angle better be in quadrant 3 when I find theta, right? Does that make sense? Do you guys see the difference between this type of stuff and me saying what is the tangent of theta equaling 1? How many answers will I get out of this one? 2, because there's always 2 places that will give me those answers, won't there? Because I am not restricting you by another trig function, right? By restricting you to a specific quadrant, I then have 2 answers I will be getting. This would be our 45 degrees, kind of like our same thing as our Bell quiz up there, and 225. Those are the 2 places that tangent is positive. Exactly. Since tangent's positive quadrant 1 and 3, I have an angle out of it. Now remember, like the last time, they restricted us to one specific quadrant. That's why there was only one answer. You guys see the difference in between when I should have 2 answers and when I should have 1 answer? This one's just saying, where is tangent equal 1? There's 2 places that happens. But if all of a sudden then I said, I want to know when tangent is 1, when sine is less than 0, which answer is that now all of a sudden going to be? 225. Does that make sense? That makes us go from 2 answers to 1 answer because there's another restriction off of that. Okay, last question, really quickly. If I gave you an equation of a line, I could ask you to go ahead and, if it goes through the origin, has to go through the origin. If it goes through the origin, I could ask you to find all 6 trig functions. Here's the reasoning. This is equivalent to y equals 2/5 x. I want to know all 6 trig functions in quadrant 3. Okay? Because here's our line. Start at 0, 0, rise 2, run 5. Agreed? But notice I want to be in quadrant 3. So what else could I do? Go down 2, back a -5, right? Would you guys agree with that? So could I draw a triangle off of that? Look, there's my triangle, huh? This side's -2, this is -5. So therefore this is square root of 29. Could I then go off of this angle right here and find all 6 trig functions? Could I find that angle? Okay. Your guys' homework. Sorry we went on a Facebook thing. That was my main reason. I apologize. 4-4. I think it's page 318. I think that's where it's at. If you guys aren't sure, just make sure you're in 4-4 section. You're going 1 through 85. Every other odd. Thanks, guys. You guys did awesome today. Thank you.